In this lesson, we are going to talk about slopes of parallel and perpendicular lines and how to find them. So by the end of the period, you are going to be able to determine lines are parallel, perpendicular, or neither by the slopes. You're also going to be able to write the equation of a line given the slope of a parallel line and a point, a perpendicular line and a point, an equation of a parallel line and a point, an equation of a perpendicular line and a point. If you're working with parallel lines, their slopes are equal. So if two non-vertical lines are parallel, their slopes are equal. If slopes of two distinct non-vertical lines are equal, then their lines are parallel. Any two vertical lines or horizontal lines are parallel. So there's an answer for you. So I guess let's look at these two. You can see the answer there. It's a mistake, but whatever. So if we're looking at these are both equations that are in slope-intercept form. Now, again, to refresh your memory, slope-intercept form is y equals mx plus b. That's slope-intercept form. So your slope is whatever's in front of the x if it's in slope-intercept form. Well, my slope on the top equation is -8. My slope on the bottom equation is 1/4. These are not equal, so the lines are not parallel. Now let's look at these two equations. We got y equals 3x plus 2, y equals 3x minus 1. Again, slopes what's in front of the x. You will see that they are the same. So these lines, if you were to graph them on a coordinate plane, are parallel. So now we have two pairs of equations here. On the left-hand side, we have y equals -x plus 20 and y equals -x plus 6. Now remember, if we don't have a number written in front of that x, you can assume that it's a 1. So the slope for my top equation is -1. The slope for the bottom equation, so top equation is -1. The bottom equation is also -1. So the slopes are the same. So are those lines parallel? Yes, they are. The right equation, they're both in slope-intercept form. We have a slope of 7 and -7. So no, the right equations are not parallel. Now let's talk about perpendicular lines. So the definition of this is a little confusing, and then we'll kind of talk more specifically what's going on here. So if two non-vertical lines are perpendicular, then the product of their slopes is -1. So if you were to multiply the slopes together, you get -1. If the slopes of two lines are product -1, then they are perpendicular. And then any horizontal line and a vertical line are perpendicular. Okay, the lines of both graphs are perpendicular. What is the relationship of their slopes? Now, we already told you that if lines are perpendicular and we multiply their slopes together, you're going to get -1. Let's test this. All right. Now, the easiest way to find a slope if you're given a graph is by counting. So I want to take this line here, we'll call it line M, okay? And we'll count from this point here to this point here. So it goes up 2 and it goes right 4. So my slope, remember, it's up and down over left and right, is 2/4, which simplifies to 1/2. We'll call this other line, and I'm going to erase this so that it doesn't get muddled. Okay. So now we'll call this line L. Now we have a point here on line L, and I'm going to use this point here because they're close, and it's where it crosses. Now again, finding the slope by counting. So it goes down 2, so that'd be a -2, and it goes right 1. So the slope of L, I'm going to write it all the way down here. That slope is -2/1. Now that, again, you don't have to write it as a fraction. It's kind of helpful. So we have our two slopes, okay? -2 and 1/2. Now I told you on the previous slide, if you were to take -2/1, that slope, and times it by the other slope, if they're perpendicular, when you multiply them, they will simplify to -1, then they're perpendicular. Well, they just did. Now, again, granted, I told you when we started this that, hey, they're perpendicular, but we just kind of proved the previous statement. What I want you to think about is there's some sort of special relationship here. Let's look at the lines on the right-hand side. let's call this line here, the one that goes down to the right, we'll call it line K. So let's calculate the slope for line K. Now again, by counting. So I have a point here and here. It goes down 2 and right 3, so 2/3. So it's negative 2/3. So my slope for line K is negative 2/3. Let's look at this line that goes up to the right. Again, let's erase some, whoops. Let's erase some of this to kind of get so that it's not so muddled. We have a point here and here for our line, what did I call it? Call it line X, why not? So it goes 1, 2, 3 up, and it goes right 2. So this slope here for line X is 3/2. Now, again, hopefully we're seeing a relationship here, but let's double check. If I take negative 2/3 and I times it by 3/2, multiply slopes together, if they're perpendicular, you better get -1. So you get -6/6. So when we multiply these, so when we multiply, or when we simplify this, you end up getting -1, which again is what I told you to do. So again, these, we told you in the directions are perpendicular. They are, okay? Think about what you notice there. So just take 20 seconds and kind of think about that. All right, slopes of perpendicular lines. Hopefully you noticed a relationship there, but they will be opposite reciprocals. So let's find some opposite reciprocals. Now, what is an opposite reciprocal? Well, when we say opposite, if I have the number 5 and I say, what's the opposite of number 5? You would say -5. Okay, if I had, 3/4 and I said, what's the opposite of 3/4? You would say -3/4. But we're talking about not only the opposite, but we're also talking about the reciprocal. Now, what the reciprocal is you literally flip the fraction or the number. Now, when you look at number 1, you're going to say, well, how in the heck do I do the opposite and the reciprocal of 2? Well, remember, when we talk about slope, it's okay to always think about it as a fraction. So if I have a slope of 2 or 2/1, the opposite reciprocal of this is I would make it negative and I'd flip it so it's -1/2. So the opposite reciprocal of 2 is -1/2. The opposite reciprocal of 2/3 is -3/2. The opposite reciprocal of -7 is +1/7. The opposite reciprocal of -1/6 is 6. Now, here's the deal. When we talk about a line that has 0 slope, hopefully you're thinking back to previous notes. That's a horizontal line. So what kind of line is going to be perpendicular to a horizontal line? Well, that would be a vertical line. So even though we said opposite reciprocal, the slope of a perpendicular line to a line that's slope of 0 is undefined because that's the slope of a vertical line. And then obviously opposite reciprocal of 1 would be -1. All right, so are the following lines perpendicular? Well, again, it's nice when we have them in slope-intercept form. If you remember slope-intercept form, that's y equals mx plus b, right? Y equals mx plus b. You can see that. It's kind of dark up there. So if it's in slope-intercept form, the slope is what's in front of the x. So when I'm looking at this, again, the y-intercept isn't really important for this. So the y-intercept here is -5/3. On the second equation, it's +2. So again, when we're looking at number 1, are the slopes opposite reciprocals? Well, the slopes are 2 and -2. So no, because it's 2 and -2. Now again, they're opposites, but they're not opposite reciprocals. Number 2, I have -1/2 and I have -2. Again, these are reciprocals, but they're not opposites. They're both negative. So, kind of like Goldilocks. Let's look at this last one here. First one's no, second one's no, third one. I have -1/2 and 2. Yes, 2 and -1/2 are opposite reciprocals. So again, when you have lines that are perpendicular, their slopes will be opposite reciprocals. So let's start putting it all together. Write an equation of a line. So write an equation of a line that's parallel to y equals negative 2x plus 1 and passes through negative 2, 3. Now, if it's parallel, they have the same slope. So because it's in slope-intercept form, I know my slope of my equation is going to be negative 2 because parallel lines have the same slope. Now we have our point. That gives me an x and a y. So I want to take that x and y, okay? So they gave me an x and a y here. I want to take that x and y and plug it in to y equals mx plus b. So I'm going to plug in negative 2 in for the x. I'm going to put in another negative 2 for the m because that's the slope in the x. And I can plug a 3 in for the y. And I'm going to solve and calculate my b. Once I know my slope, which is negative 2, and I know my b, which is negative 1, you can write your new equation, y equals negative 2x plus 1. If you were to go and get graph paper and graph these two lines, they would be parallel. Okay, so now we have, write the equation of a line that's parallel to negative 1/2 x plus 10 and passes through negative 2, 4. Again, we know your slope is negative 1/2. Remember, we're asking about being parallel, right? So that means the slopes are going to be equal. Now, again, they gave us a point. Your point has an x and a y. So you're going to plug your x and y in along with your m, and you're going to calculate your b, which is 2. You now know your slope. You know your y-intercept. The equation is y equals negative 1/2 x plus 2. Good. We are asked to find the equation of a line that's perpendicular to y equals x plus 1 and passes through 5, 8. So we know, again, talking about being perpendicular, we know that the slope is negative 1. So if I want to find my b now, you have an x and a y because they gave you a point that it needs to go through, and you have an m. So I'm going to use y equals mx plus b, slope-intercept form. I'm going to plug 8 in for y because that's what it was. I'm going to put negative 1 in for m, and then times 5 for x. I'm going to add that to b. Now just to, again, the reason why we picked negative 1 for the slope is because if my slope is 1, then my perpendicular slope is the opposite reciprocal, which is negative 1 over 1, which again, just write as negative 1. This gives me 8 equals negative 5 plus b. So add 5 to both sides. My b is 13. So my equation is going to be y equals negative 1x plus 13. Okay, now we want to know the equation of a line that passes through 6, negative 5, and it's perpendicular to the equation y equals 2x plus 3. Now, again, remember that the slope is going to be opposite reciprocal, okay? So the slope will be negative 1 over 2, negative 1/2. Why don't you take some time to actually finish this question on your own? So pause the video and try to finish this on your own. Ready? All right, so hopefully you use slope-intercept form. You plugged negative 5 in for the y. You plug negative 1/2 in for the m, and you plug 6 in for the x. So negative 1/2 times 6 is negative 3. So then you have negative 5 equals negative 3 plus b. You add 3 to both sides. So now you know your b is negative 3. So your equation is y equals negative 1/2 x minus 2. This would be the equation of a perpendicular line that goes through that point. We were given two lines, line L and line L2, L1 and L2, are neither horizontal nor vertical. Are they perpendicular? Explain. So to find that two lines are perpendicular to each other, their slopes have to be opposite reciprocals. Now, they were nice to you. They gave you nice ordered pairs on there. So you can either find the slope by calculating it that way or by counting. Okay, but find the slope of each line. So line L1, okay, the one that goes down to the right. Okay, you take -4 minus 2 divided by 0 minus -4. Okay, so just to kind of get an idea what we're talking about, I took this -4 here, minus 2, and then 0 minus -4. Again, notice that it's always subtraction. When it becomes double negative, it becomes addition. So this simplifies to -3/2. So our prediction is that if line L is going to be perpendicular, if line L2 is going to be, sorry, I keep saying L. If line L2 is going to be perpendicular, then the slope of this should be positive 2/3, because that's the opposite reciprocal. All right, let's check it. So we're using these points here. So we're taking -3 minus 3 all over -5 minus 4. Again, being consistent is extremely important. If I start with this -3 right here and I'm subtracting that 3 away from it, then you have to start with this -5 in the denominator and take the 4 away from it. Okay, so we end up getting -6 on top and -9 on bottom. When we simplify that, we get 2/3. Hey, is that the opposite reciprocal? Yes, so they are perpendicular. Now I'd like you to pause your video and I would like you to complete the next 5 questions on your own. Check your answers when you are finished.